Breaking news. At 4:18 a.m. UTC today, something happened in deep space that was not supposed to happen. At least, not according to any existing model of celestial mechanics. Moments ago, synchronized observation alerts were triggered across 3 continents as a new image set of 3I Atlas was downlinked almost simultaneously from space and ground-based observatories. The images were clear, the data was verified, and yet what they showed immediately forced scientists to pause. Today, the impossible just happened. An object that was expected to remain stable, inert, and predictable has changed, visibly, measurably, and without any known physical cause. This single update challenges everything we thought we understood about interstellar visitors. If this holds, it could redefine our assumptions about nature itself. If you want real-time updates on the universe's most unsettling discoveries, now is the moment to like this video, subscribe to the channel, and stay with us, because this story is unfolding right now. The confirmation came through NASA's automated anomaly detection system first, but it was quickly corroborated by the European Space Agency's Rapid Response Imaging Network. Within minutes, alerts propagated to research teams at Harvard, Caltech, and observatories linked to the Atacama Large Millimeter Array in northern Chile. When the first composite render was assembled, the room fell silent. The new images did not merely refine previous data, they contradicted it. To understand why this matters, we need to establish authority, scale, and context, because this is not speculation, this is observation. 3I Atlas has been under continuous scrutiny since its identification as an interstellar object. NASA's Jet Propulsion Laboratory has been tracking it using combined inputs from Hubble, the James Webb Space Telescope, and ground-based spectrographs distributed across South America, Europe, and Australia. ESA's European Space Network provided precision Doppler measurements, while Caltech-led teams ran real-time orbital simulations to predict every conceivable change in trajectory, brightness, and composition. Until now, those predictions held. The Atacama Array observed 3I Atlas in the millimeter and sub-millimeter bands, confirming thermal stability within a margin of 0.3 Kelvin. jwst's infrared spectrographs showed no unexpected emissions. Hubble's optical imaging revealed a consistent silhouette, unchanging, symmetrical, and inert. Data from Australia's Deep Space Tracking Network confirmed no anomalous acceleration. In short, 3I Atlas behaved exactly like an inert interstellar remnant should, until today. The new images came from a coordinated imaging window scheduled weeks in advance, timed to capture 3I Atlas as it crossed a region of relatively low solar interference at a distance of 2.14 astronomical units from the Sun. 48 hours before the event, nothing appeared unusual. Brightness levels were steady. The object's effective cross-section remained constant. Spectral signatures aligned perfectly with earlier observations. Then, 11 hours before the event, a subtle deviation appeared. At first, it was dismissed as noise. A minor asymmetry in reflected light detected independently by ESA's La Palma Observatory and NASA's Pan-STARRS system in Hawaii. The deviation measured less than 0.6%, well within the range of instrumental error. No alert was issued. 6 hours later, the anomaly doubled. At 22:41 UTC, spectroscopic data showed a shift in the object's surface reflectivity across the near-infrared band, centered around 1.6 microns. This was unexpected. No known interstellar material exhibits a spontaneous reflectivity shift without a corresponding temperature change, yet thermal readings remained flat at approximately 78 Kelvin. 3 hours later, the first image arrived that no one could explain. The silhouette of 3I Atlas had changed, not dramatically, not explosively, but unmistakably. Its previously smooth, elongated profile now showed a precise indentation along one axis, as if a portion of its structure had subtly reconfigured itself. The change was symmetrical, controlled, and absent of any debris field. No fragments, no dust plume, no outgassing. No natural process could produce such symmetry without violence. At 0109 UTC, jwst confirmed the change in infrared. At 0112 UTC, Hubble confirmed it optically. At 0114 UTC, the Atacama Array confirmed it thermally. This was not an illusion, it was not an artifact, it was real. Then came the acceleration data. For years, 3I Atlas had followed a predictable trajectory at approximately 42 kilometers per second relative to the Sun. But new Doppler measurements indicated a deviation, small but statistically undeniable, a change of 0.19 kilometers per second. Not enough to classify as propulsion, but too precise to be explained by solar radiation pressure or gravitational perturbation. The team recalculated everything. Gravitational modeling showed no nearby masses. Solar wind conditions were stable. Magnetic field interactions were negligible, registering less than 2 nanotesla, far below any threshold capable of influencing an object of this scale. And yet, the change persisted.
At this point, an internal investigation was launched. Simulation teams at Caltech and Harvard began running high-resolution models incorporating exotic variables, volatile phase changes, internal structural collapse, even rare quantum scale effects amplified over macroscopic distances. None of them fit. Dr. Elena Moravec, a computational astrophysicist working with ESA, described the moment bluntly. The model stopped converging. No matter how parameters were adjusted, the system refused to behave naturally. Meanwhile, spectroscopy revealed something even stranger. A new emission line appeared briefly at 4.3 microns, lasting exactly 73 seconds before vanishing. The energy level corresponded to no known molecular transition expected in inert interstellar matter. The emission repeated once more, precisely 19 minutes later. Then again, exactly 19 minutes after that. Prime number intervals. At this stage, opinions began to divide. The mainstream explanation, supported by several planetary scientists, argued for an exotic but natural process, a previously unknown form of internal restructuring triggered by long-term cosmic radiation exposure. According to this hypothesis, 3I Atlas could be composed of layered materials that undergo phase transitions under very specific thermal histories. But there was a problem. Phase transitions release energy chaotically. This did not. An alternative hypothesis emerged quietly at first, discussed only in closed meetings. What if the object was not reacting, but adjusting? What if the observed changes represented controlled reconfiguration rather than decay? That suggestion was met with resistance, understandably so. Still, the data continued to complicate matters. At 0932 UTC, a second wave of anomalies occurred. A localized electromagnetic disturbance was detected along the object's trajectory, measured simultaneously by ESA's solar orbiter and a magnetometer array in South Africa. The disturbance lasted 11 seconds and exhibited a harmonic structure inconsistent with solar noise. At the same moment, one segment of 3I Atlas, previously identified as a surface irregularity, simply vanished from all sensors. No explosion, no radiation spike. It was just gone. This was no longer random. It was responding. Control rooms grew tense. Internal communications were encrypted. Observation schedules were rewritten in real time. Data access was temporarily restricted while agencies verified integrity and security. On Earth, subtle effects began to ripple outward. Several low Earth orbit satellites experienced brief communication dropouts lasting milliseconds but synchronized in timing.
High-frequency radio operators reported unexplained interference. Magnetometers in northern latitudes recorded faint but unusual oscillations. Even biological systems appeared to react. Avian migration tracking programs noted short-term deviations in orientation patterns. None of this was catastrophic, but it was coordinated. And coordination implies intent, or at least structure. As the data poured in, the narrative shifted from observation to implication. Not panic, but unease. Not certainty, but possibility. In the calm after the chaos, there was time to reflect. For centuries, humanity has scanned the skies assuming that the universe is passive, that objects move, collide, decay, and disappear according to fixed laws. But what if some of those objects are not merely subject to physics, but participants within it? Maybe we're not witnessing the end of certainty, but an invitation to expand it. The final images of the day showed 3I Atlas continuing on its path, outwardly stable once more. But now, its shape is different, its behavior is different, and our understanding is different. The last data packet included a final anomaly, a faint alignment shift orienting one axis of the object toward the inner solar system for exactly 88 seconds before returning to its prior orientation. Why? What changed inside it? And what happens if it changes again? Subscribe to stay with us. The next update is already being analyzed. The story of 3I Atlas is not over, and whatever this object is, it has not finished surprising us.